I have a new example up here with a new keyword called elsif, which if it was up to me, I would write it with an E over there in like English. But for some reason, the creators of Ruby decided to spell it like that. And you could probably read this. It reads sort of like English. But we're basically grouping 3 conditions together. And here we have Harold is 5. So we're creating the variable called Harold, which is a nickname for 5. We then say if Harold is greater than 5, then print the number 100 to the terminal. Else if Harold is less than 5, print the number 200 to the terminal. Else, if neither of those 2 conditions are true, then print 300 to the terminal. How is it possible that neither of those conditions can be true? How could it be Harold is not greater than 5 and it's not less than 5? If it's equal to 5. So my translation of this else is if Harold is equal to 5. So in this case, when I run this code, what will print out in the terminal? Yeah. So it prints out 300 because it is this else condition that is true. Now, remember how we spoke about when we dealt with if and else, we said we could only go down one of these 2 paths. We never go down 0 of the paths. We never go down both of the paths. We only choose 1 out of 2. When you group 3 or even more conditions this way in one large statement, we only choose one of the paths. So if there are 3 possible paths here, we only choose one of them. It's always just going to be 1. Now, if Harold is, say, 4, then the path that we follow is this one, right? Harold is less than 5. If Harold is 6, the path we follow is this one. But whatever Harold is, only one of these 3 paths are going to be triggered. Elsif is basically used if you have 3 or more possible paths to go down. So with just 2 possible paths, you could get away with if and else. If you have 3, as soon as you hit 3, you're going to need to start using elsifs. You start with an if, and then everything else is elsif, 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 and the last thing is else. Else meaning otherwise, if none of these previous conditions happen or true, then do this last thing. It's like the catch-all. And we're going to see more and more examples of this. In fact, the next example involves quite a few elsifs. Let me pull it up. Okay, here we have, we're creating a variable Yolanda, which is 10. A lot of possibilities here, and this is tricky right here, and you'll see why. So let me just read you through it. If Yolanda is less than 5, print 1. Else if Yolanda is greater than 5, print 2. Else if Yolanda is 10, print 3. Else if Yolanda is less than 10, print 4. Else if Yolanda is less than 100, print 5. What's tricky here is that sometimes more than one of these conditions seems to be applicable. So let's walk through this and see what we think Ruby might do. So we know in this example Yolanda is 10, right? If Yolanda is less than 5, is Yolanda less than 5? It is not. So that means we're going to skip line 4, correct? Okay. Else if Yolanda is greater than 5. Is Yolanda greater than 5?
Yes.
Yes. So we're going to run line 6, right? And that's going to print 2 to the terminal. Cool? Here's the tricky question. Line 7. Else if Yolanda is 10. That's true. Yolanda is 10. But do we print 3 to the terminal? Let's do a vote. Who thinks that it prints? Who thinks that it doesn't print? Okay. So since most people said it doesn't print, we're going to go with that. Because that's true. So the key with elsifs is that, like I said before, we always choose just one path. When you have a bunch of conditions together, elsif, 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 the way Ruby works is we always just go with one path. How does Ruby decide to go down, and let's just show this, right? It just prints 2. why does Ruby decide to go down this path? Because Yolanda is greater than 5. Isn't that arbitrary? Why couldn't Ruby instead to print 3 and go with this condition of Yolanda being equal to 10? Because that is also true. In fact, Yolanda is also less than 100. So why did Ruby decide to print 2 as opposed to print 3 or print 5? Yeah. So since Ruby, the answer is it encountered that one first. And Ruby reads, again, every line top down. Sometimes it skips with if statements, but it always goes top down. So this is the way Ruby reads it. Yolanda is 10, noted. If Yolanda is less than 5, that's not true, so we skip that line. Else if Yolanda is greater than 5, that is true. We print 2, and Ruby says, oh, there's more else ifs here. I can ignore all of that. Because the rule is that we've executed one path. That's all we're going to execute. That's the way it works. Ruby divisors could have made it that Ruby doesn't do that. It might execute all the various paths that are applicable, but it doesn't. Execute one, and then it jumps out of the hole, just skips to the end. One other thing I want to point out is, if you notice, I actually don't have an else clause at the end. You don't have to have an else. I just have else ifs. So that's another interesting thing to note. You don't have to have an else. You don't have to have else if. I mean, it depends what you're doing. Okay. Well, actually, it's worth going down that rabbit hole a little further. Let's say I did have an else. How would you say this else in English? It's rough, right? Basically, if none of these conditions apply. Is it possible to come up with a number where none of those conditions apply?
Complex number. Well, it's a good idea to have it, though, just in case you screw the top part up, maybe.
Maybe. I can't think of a number. I don't know math, so I don't know complex numbers, but I mean, I don't think I can come up with a number because any number is for sure going to be either less than 5 or greater than 5. And if you'll tell me 5 itself, that's less than 10 and less than 100. So I can't come up with any number that. So that's why I don't have an else there. But if else, we're basically saying if somehow we got to this point and none of the previous conditions apply, then we'll do this. Think of it as like the multiple choice test where the last choice is none of the above. That's else. And just like in a multiple choice test, ooh, I like this analogy. Just like in a multiple choice test, you can only choose, in most of them anyway, just one answer. Same applies by if statements. Just one answer. Okay. Now, let me throw everything on its head. I'm going to modify this code to this. I'm going to break up the if statements to this. So it's the same as before, the same conditions. However, instead of putting it all together in one if statement with else ifs, I've broken it up into 5 independent if statements. What will happen? So let's walk through it. So Yolanda's 10. If Yolanda is less than 5, is it less than 5? No. So we're going to skip 4, right? So Ruby reads this. That. I'm going to skip the blank lines for now. That. If Yolanda is greater than 5, is Yolanda greater than 5?
Yes.
So will it print 2?
Yes.
Okay, here's the key question. If Yolanda is 10, right? Yolanda is 10. Will this line, line 12, will that run?
Yes. Yes.
Should we vote? Who thinks yes? Who thinks no? So the answer is yes. And it runs the 4. And similarly, if Yolanda is less than 100, which it is, it prints 5. This is what happens when we break up the statements. They're not tied together as we could only choose one of several paths. Ruby goes through, since we've broken them up into independent if statements, Ruby is not stopped from just plowing its way through all of them and processing all of them. Does that make sense? That is the subtle but crucial difference between the elsifs that are put together and these separated if statements. That is the difference between them. Because one would ask, why do I need elsif? Why can't I just do this? The answer is there's a difference. With elsif, you're ensuring that only one of the paths are taken. Here, it's possible that multiple of these things might happen.